Let's kick this explainer off with a hard truth. A CAPTCHA solve can succeed, and your production workflow can still fail. If you're an automation developer or a technical lead, you probably know exactly what I'm talking about. Today we're going to set a really focused tone and tackle a major headache in automated workflows: bulkhead design around CAPTCHA calls.
So, a CAPTCHA solve can succeed and your production workflow can still fail. That right there is the core paradox. It's the exact problem so many teams slam into right after moving from a simple, local test run into a real, live automation environment.
Okay, let's dive into Section 1, the production reality. You might be wondering, why does a happy path manual test behave so differently than unattended execution? Well, in a manual test, everything usually looks perfectly fine, right? The CAPTCHA pops up, the task is submitted, a result comes back, the token is applied, and boom, the workflow continues. But production? Production is a whole different beast. Now, that exact same flow has to run inside a cron job, a CI process, an internal queue, or a worker pool. It literally has to survive network delays, deploy windows, sudden session changes, CAPTCHA updates, retry spikes, and downstream rejections. It's absolute chaos.
Which brings us to Section 2, the reliability checklist.
See, the hard part isn't actually just solving the CAPTCHA. The real challenge is operating that solving step reliably in the middle of all those chaotic variables we just talked about. So the better question isn't, can our system solve the challenge? The better question to ask yourself is, can it solve it predictably, apply it correctly, recover cleanly, and actually prove that the workflow succeeded? To help with that, we've got a 5-step checklist. Think of this as your home base for bridging the gap between a simple solver result and actual predictable success.
Step 1. Validate your exact request inputs. Listen, before submitting a task, you need to capture only the parameters the CAPTCHA family actually needs. That might include the site key, the page URL, action, method, and maybe some optional proxy details. But whatever you do, do not guess here. You've got to inspect the live page or network call and absolutely confirm your code is sending the correct values. Sending wrong inputs just creates these false debugging paths. I mean, if the page URL or site key is wrong, no retry strategy in the world is going to fix your workflow.
Moving on to Step 2, control your polling cadence. Polling too often, that just creates noise, extra load, and super messy logs. But polling too slowly adds entirely avoidable delays. A truly reliable workflow should wait about 15 seconds before that first poll, then poll at a consistent 5-second interval. And finally, this is absolutely crucial, hit a 120-second hard timeout. The main takeaway here is that every single task needs a maximum runtime. Seriously, never let a task wait around forever.
Okay, Step 3. Apply a token in the same session. Believe it or not, this is actually one of the most common production failure points. A CAPTCHA token might be totally valid, but it'll still get rejected if it's applied in a different browser context, HTTP client, cookie jar, or session than the one that initially triggered the challenge. So, you have to keep the solve and the form submission inside the exact same session. Honestly, treat session continuity as a strict production requirement, not just some minor implementation detail.
Step 4, set a retry budget. Now, retries are great when they're handling temporary hiccups, but infinite retries? That is not true resilience. Infinite retries just hide defects, burn through your budget, and make debugging a total nightmare. What you want to do is use a capped retry budget with an exponential backoff. And make sure to log every terminal failure with enough detail so you can actually investigate it later. If your workflow just keeps retrying after wrong parameters, rejected tokens, or broken session handoffs, your costs are going to skyrocket while your reliability stays exactly the same. No thanks.
All right, let's look at Section 3, measuring true success.
You know, a solver result is just not the same thing as a completed workflow. Tracking both your solver success and your downstream acceptance is what actually gives you a full picture of your pipeline's health. You definitely need to track the solver success rate per CAPTCHA family, ideally targeting 95% or higher. But you also absolutely must track that end-to-end downstream acceptance post-token. Along with that, you'll want to monitor your first solve latency and the specific reasons for any terminal failures.
And this brilliantly illustrates the point. If your solver success is high but your downstream acceptance is low, the problem probably isn't the solve itself. That post-solve rejection gap usually means your integration is failing somewhere down the line, maybe due to application logic, page changes, or, like we covered a minute ago, bad session handling. Now, tracking cost per solve is a useful metric, sure. But measuring the cost per accepted solve, that is a much more honest metric. Why? Because it directly reflects the true business value of a completed outcome. Your volume should scale linearly with successful accepted solves, not with out-of-control retry storms.
This leads us nicely into Section 4, Mistakes and FAQs. Let's rapidly review some common pitfalls. These are the specific mistakes that turn simple technical defects into massive ongoing infrastructure costs. Mistake 1, tracking only solver success. Doing that just gives you false confidence. Mistake 2, applying tokens in a different session. Like we said, that's a massive cause of post-solve rejection. Mistake 3, using aggressive polling without a hard timeout. Mistake 4, allowing unlimited retries. And mistake 5, grouping all your errors together. Listen, distinct issues like zero balances, bad parameters, and timeout issues absolutely have to be tracked separately.
To wrap things up, let's run through a quick FAQ. Why can a solve CAPTCHA still fail? Well, usually post-solve rejection happens because the token was applied in the wrong session, the page changed underneath you, or the downstream application simply rejected the workflow. Oh, and as a quick note straight from the source material, this type of automation workflow should only ever be used in owned, client-authorized, or contractually permitted environments.
So, what does this all mean? The practical takeaway here is pretty simple. Reliable CAPTCHA workflows are not built by solving one challenge successfully in a quick demo. They're built by carefully controlling inputs, applying results correctly, and monitoring the gaps. I'm going to leave you with this one provocative question to think about. Are you measuring solver success or actual workflow success? Rethink your integration metrics, and you'll be well on your way to building truly predictable pipelines. Thanks so much for joining me on this explainer.